Okay, hi everyone. As we promised, we're continuing the estimation of square roots of non-perfect squares. So in this case, we will discuss first a generic process and then some observational process also, wherein if you know certain perfect squares, you can utilize those perfect squares. So let's start with an example here. Let's say we need to take a square root of 800. Now, in order to get the generic process, using the generic process, you need to get this perfect square, you must be knowing the square, the perfect square, which is just below 800. Okay, so in this case, I mean, 800 is not a perfect square. What you need to know which is the perfect square just below it. So that is 28 in this case. 28 square is 784. You can try and estimate that using some techniques. If you know how to square numbers and all the shortcuts that we discussed earlier, using that you can try and estimate some values. We'll leave that for now. If required, we would discuss. Just comment below. So first thing we are calculating I mean, we are trying to figure out the perfect square which is just below this 800. So that is 28 square. And 28 square is also important here. So just take a mental note of that. So that is 784, right? Now the rest of the part is easy. What we are going to do is first we are going to get a fractional equivalent of the number, and then we are going to estimate the decimal value of the same. So what we are going to do is in order to get the fractional equivalent, the numerator would be simply the difference between these two values. So the 800, that is the number whose square root we are looking to find, and the perfect square just below it, whatever is the gap. So the gap is going to the numerator, so 16. And for the denominator, the process is very simple. What you do is, whatever this number was, you just put a double of that in the denominator. So that is 56. So simply put 56 here. So now this, you can just even reduce this. So what you get is something like this. And approximately that would be 28.28. Right. Now you can even check with calculators, and even if you don't have to, I'll just show you another method for this special scenario. So if you have 800, uh, of course, you can observe that 400 is a perfect square, right? I mean, 800 is 400 into 2, out of which 400 is a perfect square. So if you take that 400 outside the square root, so that comes out to be 20, and then you have 20 root 2. And if you remember the square root of root 2, that would be 1.414. So these are those techniques. I mean, when you know a perfect, I mean, a square root. So if you know the value of root 2, root 3, root 5, this helps sometimes. But traditionally, I would say this process is pretty fast. You can This is a generic process, and this process is pretty fast. Provided the only constraint is that you need to know a square which is just below the number that we are trying to square root. So once you know that, then the process becomes easy, and hopefully you can practice this a bit and become a little fast on this, because the only challenge would be to convert this fraction to the decimal part. So again, that division thing comes into play. So if you're good with some percentage values and some division methods, then again that should not be a big problem. So thanks again for joining in. We'll continue the session with some special techniques, and see you in the next video.